11.2, use combinations in the binomial theorem. Let's take a look at 5 teams and how we would match them up to play each other. You notice that this is a list of permutations. These are all the possibilities of 5 chosen 2. Now let's go ahead and eliminate the duplicates because playing a team, whether it's A and B or B and A, are the same. And in that case, you really have 10 different matchups. So this is called a combination. So combinations are a permutation where you eliminate the duplicates. And so here's the formula. It's really a permutation divided by the number of duplicates here. Okay, if I go ahead and change that permutation, here's the permutation formula, and then here's dividing by the duplicates. And again, this is a formula where order is not important. Let's take a look at dealing a deck of 52 cards. How many ways can we have 5 cards handed to you? So this is a combination because order is not important. It would be 52 chosen 5 ways. So the formula says 52 factorial all over 52 minus 5 factorial times 5 factorial. Now by hand, we can do this. And at 47, I won't keep going, I'll just say 47 factorial. Now this is also 47 factorial and 5 factorial, so we can easily reduce here. And then our reducing is much easier. I'm going to leave the rest up to you to be able to do that. Okay, let's go ahead and practice with some smaller numbers. So we have, this is going to be 8 factorial. And then we're going to do 8 minus 3 factorial. This is the permutation, and then we're eliminating duplicates. So this is 8 times 7 times 6 times 5. And then this is going to be 5 factorial. Oh, I should say 5 factorial here. And this is going to be 5 factorial over 3 factorial. So the 5 factorial is going to reduce here. And we're going to have 8 times 7 times 6. All over 3 times 2, 6 will reduce here, and the answer is 56. The calculator is also willing to do that. Let's go ahead and clear, go to math, and then you're going to go over here where it says probability, and you're going to choose 3, and we're choosing 8 and 3. Choosing 3 at a time, and enter, and we get the number 56. All right, so there are 2 things we're talking about, permutations and combinations. Let's take a look at A. There are 30 dogs in a show. Blue ribbons are awarded, not in order, they're just awarded. So this is an example of a combination of 30 chosen 3. Now here on the runners, we do have a first, second, and third, so that would be a permutation of 30 chosen 3. Your turn. Here's the answer. Your turn. Here's the answer. Your turn. Here's the answer. Let's now take a look at how combinations relate to what we call Pascal's triangle. Now this is Pascal's triangle, very interesting pattern. 1, 1, 1, and then right over here on this line, we are going to start with 1, and then we're just going to add these 2 numbers to make 2, and then we end in 1. Start with 1, add these 2 numbers, 3, add these 2 numbers, 3, and then end with 1. Start with 1, add these 2, 4, add these 2, 6, add these 2, 4, and so on. These numbers are also aligning with the numbers that you get with combinations. So if this is the second row, combination of 2 chosen 0, combination of 2 chosen 1, and so on. These all match well together. Now, if we wanted to do a problem, the Model UN Club, and there's 6 members and 2 representatives chosen, that would be a combination of 6 chosen 2. Well, 6 chosen 2, that would be in our n equal to 6 row. Let's go ahead and create the n equal to 6 row. That would be 1, 6, 15, 20, 15, 6, and 1. This would represent combination of 6 chosen 0. That would be that one. This one would be combination of 6 chosen 1. And this would be a combination of 6 chosen 2, which is what we're trying to get. And so the answer is 15. So here's another way to find these values without going to the calculator. Okay, where have we seen these kinds of things? Well, we've seen them when we are multiplying binomials together. So this is, hopefully you remember, this is our FOIL, first, outer, inner, last, that's what we get. Well, when we do it times 3, that's a little bit more involved multiplication. But when we multiply it out, this is the answer we get. Notice that the coefficients are the same as Pascal's triangle. If we do it to the 4th, that's a bear to multiply it all out. But notice that again, the coefficients are these numbers that we find in Pascal's triangle. Continuing with the things that we are seeing also is not only do we get these Pascal triangle numbers, but I want you to notice that the exponents, so this a to the 4th, and then the second term is a to the 3rd, a to the 2nd, and then you can count this as a to the 0 if you wanted to. And notice how the b's on each term are going up. So this, we could consider this as b to the 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th. And at all times, remember that these degrees always add up to 4. 4, 4, 4. This is a 1 power 4. So it's kind of an interesting relationship here. All right, let's take a look at a problem that's done for us, and we are expanding this. It would be terrible to have to multiply this all out. But notice that the coefficients are our combination numbers, and notice that we're taking this number to the power 3, then to the power 2, power 1, and to the 0. And then we're taking this, y, to the 0 power, to the 1st power, to the 2nd, and to the 3rd. And when we multiply things out, we get this a lot easier than having to multiply by hand. Now, what happens if you have a subtraction problem? When you have a subtraction problem, just make it into an adding and put the 2 as a negative, and just treat this all together. And so you'll treat it this way, going up in powers here. And in the end, you will get some negative numbers at the outcome, but you don't have to worry about that. We can use the same strategy that we did before. All right, so let me do one by hand to help you out. So I know this is to the 5th power, so this is going to be a combination of 5 chosen 0, and then x to the 5th power times 3 to the 0, plus combination of 5 chosen 1, and we're going to go down a power, and 3 is going to go up a power. Combination of 5 chosen 2, go down a power for x, go up a power for 3. Combination of 5 chosen 3, x to the 3rd power, 4th power, and no, it's not 4th power, we're going down the powers. So this is 2 times 3 to the 3rd, plus combination of 5, 2, x, and then times 3 to the 4th, plus combination of 5 chosen 1, and that's x to the 0 times 3 to the 5th. This should have been a 4, and this should have been a 5. I wasn't going up my patterns here correctly. Okay, let's do it with this problem right here. And when I do this problem, a lot of times I don't use my combination formulas. I actually use Pascal's triangle. And this is a 2nd degree, this is a 3rd degree, and I didn't do that right. This should have been a 3. And then my 4th is going to be 1, 4, 6, 4, 1. So I'm going to use 1, and then I'm going to use a to the 4th power, and then 2b to the 0, plus 4, a to the, going down a power, and then going up a power, 6, a to the 3rd, that's not the 3rd, it's the 2nd, because I'm going down a power, 2nd, and then 2b, and I'm going up a power, plus 4, a to the 1, 2b to the 3rd, plus, and then I'm at 1, a to the 0, and then 2b to the 4th. Now we can simplify this, a to the 4th plus, and this is going to be a 2 times 4, which is 8, a to the 3rd, b. This is going to be 4 times 6, which is 24, a squared, b squared. This is 8 times 4, 32, a, b to the 3rd. This is 16, b to the 4th. Okay, your turn. And here are the answers. And the binomial theorem can be written this way, where instead of using the combination formula, we use this symbol instead, which still means a combination of n chosen r, but it's a little cleaner looking. Okay, now let's try to find a coefficient in the expansion. So instead of multiplying or looking at it, writing it all out, let's see if we can just find the coefficient of 4. Now the coefficient of 4 will mean that eventually we have to be taking it to the 4th power. And so we're going to take this 10, take away, to get to the 4th power, you're going to have to subtract 6. So we're going to use r equal to 6 to create this 4th power. And then our r is going to be, that same r is going to be used here, and it's going to be used here. So because this was 4, 10 take away 4 is going to be 6, and r will be equal to 6, because that's going to help us create that 4 right here. And when you multiply everything out, you'll get this answer. Okay, so let me do one where I do the problem here. So I want the x to the 5th. Now this is the 7th here. So in order to get a 5th power, I'm going to have to say 7 take away 2. And when I take 7 take away 2, that'll give me a 5. And this is my r. That is the r I want to use. So this is going to be C, combination of 7 chosen 2 times, and then this is going to be x to the 7 take away 2, that'll create that 5, and then times, I'm going to write -3, and I'm going to use continue to use my r, which is 2. So I'll find combination of 7 chosen 2, and that is and that number is 21. So this is going to be 21 x to the 5th, and then this is going to be 9, so that will be 189 x to the 5th. And so to answer the question, this will be the coefficient. Your turn. And here's the answer.